All right, temperature drop across the condenser. This is going to be a quick video. All I'm going to do is show you. So I have one temperature probe connected to the inlet, so that'd be hot vapor coming from the compressor going in. Then I have the other one on the outlet coming out. That's on the subcooling circuit, because these last few lines is subcooling liquid. Everything else up here is gas. Everything below this little line you see right here, that is subcooling. Everything here, subcooling liquid. Everything up above, gas. Minute amount of liquid as you get down in there. So let's see, we got 49 degrees. That is our TD. You can see that right there. TD, your delta T between the two. You got 92 degrees coming out. You got 141 degrees going in. So going in at 141, coming out at 92. That's your delta T. Now, we have a heat exchanger. Let's look at some temperature changes. Let me grab this guy right here. And we're going to go after the heat exchanger. So let me grab a piece right there. I could get that. Right. There we go. So that's the suction line before or after, however, which way you want to word this. But if you look right here, here's the liquid line going in. This is the internal heat exchanger that has liquid traveling on the outside of the suction line returning to the compressor. So I am after, let me get this, is making me dizzy. There we go. So I am after the heat exchanger if you're talking about the travel of vapor refrigerant coming back. What's supposed to be cold, so that should be cold. What temperature is it? It is 70 degrees, what puts it at 112 degrees of superheat. Do I have that on the right refrigerant? Yes, I do. So now let's take the temperature after, or whatever. Right there, you can see the liquid line coming out right there. That's where it ends. Right there out of the evaporator, that's where it's really cold. So let's grab this, and remember, there are 69 degrees, 69.7. We're taking it off of there, and now we're gonna put it before or after, however you want to put it in your wording, right there. Now we're grabbing on to the same suction line, but we are before the internal heat exchanger. Now look at the temperature. 39 degrees, 38 degrees. So that internal heat exchanger is doing a lot of work of removing heat out of the liquid line. Remember, our liquid line right here was 92 degrees. And we have 92 degrees going in, and then the heat is being absorbed out of the liquid into the suction line to deliver that heat back to the compressor to reject it through the condenser. But on the other side, the liquid line will drop temperature. So remember, it was 92 degrees right here. So let's grab this, and that was 140 degrees. Let's put it right here. Right there. There we go. It's dropping temperature because it's cooling off, because it was really hot from being on the 140 degree line. So you got to give it a little time. Let's call that good enough for government work. 95, it'll probably go down to 94 degrees. So let's round it off, just say 95 degrees. So it's 95 degrees exiting the subcooling part of the condenser. So now let's take it off of there, and let's put it after, and take right there. There we go. Now we're after the intercooler. So now it's been subcooled. Let's see what the temperature that liquid has dropped down to. Did I do that right? Where's that guy? Let me make sure I got, let's see. 85 degrees. So almost 10 degrees of subcooling is added. 11 degrees of subcooling has been added from the 96 degrees right here to 84 degrees on the other side. Almost 12 degrees of subcooling has happened by heat being rejected, being absorbed out of the liquid into the vapor to come back. All right, guys, see you later. Oh, field piece. SM480V if you're curious. True Tech Tools, I have my offer code over there, saves you 8%, all one word, all capital letters, LECHAIR, get you 8% on discount. All right, see you guys.